This is the tutorial for Chapter 6, Section 3, titled Solving Systems Using Elimination. We're on day 1. So let's take a look at elimination rather than substitution to solve. And so let's see how that's done. So with substitution, we'd have to solve for one of these variables. But this is a lot easier when we're using substitution. And the reason why is when we go ahead and solve this, all we end up having to do is eliminate one of these unknowns. And so let's take a look at our first problem here. So what I'm going to end up doing is just adding these two equations together, and you'll see what ends up eliminating in this case. So since we've got a negative 6y and a positive 6y, the y's end up eliminating, and I'm left with 8x equals, and then I end up having to subtract these two numbers, and put the bigger number on top. When you do that subtraction, you'll see you end up with 16. And so when I go ahead and divide by 8, I end up with x is 2. So that gives me my x value really fast. I still have to substitute back in to solve for my y value. So either equation will work. I'll pick the bottom one there. 3 times by 2 plus 6y equals 48. And so I'll get 6 right here, so I need to subtract that from the 48, and I'm left with 6y equals 42. So when I divide by 6, you can see how I'm getting y equals 7. So my point is 2, 7. So this method works really good if you can eliminate something quickly. Over here we can do the same thing. See, the x's will end up canceling because when we add the two equations, we end up with 0 here, so at least 0x. Over here though, it makes negative 7y. Same sign, so that's why I added. Over here we get 14, so you can see it works really well when we can eliminate one term quickly. So in this case, we get y equals negative 2. So you just take that value, substitute into one of these two equations. Again, I'll take the bottom one, 3x minus 4, and in place of y, you're putting negative 2 equals 5. So I'm left with 3x plus 8 equals 5. So when I go ahead and subtract the 8 from all sides, I end up with this, 3x equals negative 3. So divide by 3, and we're left with x equals negative 1. So our 2 points are going to end up being negative 1, negative 2. So that's where the two lines end up crossing. Now the problems get a little bit tougher when we can't add them together to cancel out a term. See, if I added this, I wouldn't be able to cancel out the y's or the x's. So I need to modify one equation, or sometimes both. In this case, I could just modify one. So if I multiply this bottom equation by 3, watch what happens to the y term. So I'll get 21x, much bigger number there, but look, I get negative 15y, and this all equals 51. So if I look at this, bring this bottom or this top equation down, I've got negative 2x plus 15y equals negative 32. So when I add these together, notice how those y's now cancel. And so when I go ahead and combine the x's, I'm left with 19x, and this all equals, going to borrow a little bit, and that changes to a 19 as well. And so when I go ahead and do the division, I end up getting x equals 1. So once I get that, I take that value of 1 and substitute back into one of the two equations. So no matter what, you'll still have to do the substitution. It's just the first number's a little bit easier to come up with. So I go ahead and substitute the 1 in for x. Negative 2 times by 1 plus 15y equals negative 32. So I'll go ahead and multiply. Negative 2 plus 15y equals negative 32. So I have to add the 2 to both sides. So 15y equals negative 30. Do that division, and you end up with y equals negative 2. So those are my point. That's my point. 1, negative 2, where the two lines end up crossing. So elimination gets really tough when you can't just multiply one equation by a number, you need to multiply both equations. So you get to choose which one's easier to eliminate. I'm going to choose to eliminate the y's. I'm going to multiply this top one by negative 3, the bottom equation by positive 2. And so when I do that, I'm left with negative 9x plus negative 6y, or just minus 6y, equals negative 3. So on the bottom I get 8x plus positive 6y equals negative 4. So when I add this together, See, those y's cancel out. And this one's really nice because it leaves me with just negative x equals negative 7. So if I divide by a negative 1, that's going to cancel out the negatives, leaving me with x equals 7. So now I still have to substitute. So I'll go ahead and substitute in the top equation this time. 3 times by 7, and then plus 2y equals 1. So I'll go ahead and multiply there. 2y plus the 21 equals 1, so I'll subtract the 21 from all sides. I'm left with negative 20 equals 2y. So dividing by 2 gives me my answer. Y is negative 10. So I get the answer is 7 comma negative 10. So let's take a look at some word problems that could end up seeing. First one here says, suppose you got 8 mangoes and 3 apples for $18. So it says over here, 3 mangoes and 5 apples for $14.50. How much does a mango and an apple each cost? So mango, let's call M the cost of a mango, and let's call A equals the cost of an apple. And so we're going to set up the first value equation. It goes this way. 8M plus 3A equals 18. 8 mangoes, 8 times the price of a mango, plus 3 times the price of an apple equals $18. Where the other equation would be 3m plus 5a equals $14.50. Again, we have 3 times the cost of a mango, 5 times the cost of an apple equals $14.50. So great elimination problem. Whenever m's, a's, and constants are all lined up, elimination works really well. It's a tough one though because we've got to multiply by a number that will end up canceling out one of the terms, so we have to multiply both. And so I'm going to choose to eliminate the m's this time. So I'm going to multiply this bottom equation by, let's go ahead and multiply it by negative 3, and we'll multiply the top one by 8. So I'll go ahead and do that. I am left with a negative 24m minus 9a equals, this makes a negative 54. Now on the bottom I end up with a positive 24m because 8 times 3 is 24 plus 40a equals, and then off to the side I'll go ahead and use the calculator here, and I've got 8 times by 1450 gives me 116. So when I go ahead and add these two equations together, notice how the 24m's are going to cancel. So I see I have 31a equals, and I'll pull up that calculator again, I'll subtract that 54, since they're opposite in sign, leaves me with 62. So I can go ahead and do that division. I see that goes in there 2 times. So a equals 2. So it's $2 for an apple. And now let's find the cost of a mango. So we'll just substitute in. So I'll use the top equation. 8 times m equals 3, oops, not equals, but plus 3 times by 2 equals 18. So that's 8m plus 6 equals 18. And I'll subtract the 6 from all sides. And I'm left with 8m equals 12. So when I go ahead and do that division, it's not going to go in evenly, but that's okay. M equals, and 8 goes into 12 one time, and we have 4 left over, so that's going to leave us with a half. So $1.50 is the cost of the mango. So let's take a look at the next one. Similar type of problem. It says shoppers purchase 4 tables and 2 chairs for $200, 2 tables, 7 chairs for $400. What is the cost of each table and each chair? So we're going to say that T equals the cost of the table, where maybe C equals the cost of the chair. So let's do 4T plus 2C equals 200. So 4 tables, 4 times the cost of the table, 2 times the cost of a chair is going to be $200. So 2T, so 2 times the cost of the table, plus 7C, 7 times the cost of a chair, equals 400. So in this one, I could just get away with multiplying one of the equations. I could multiply the bottom equation by negative 2, and that's going to cancel out the tables. So I got to do every single term there, so we end up with negative 4t minus 14c equals negative 800. So if I bring this equation down, you'll see it, the addition a little bit easier here. And I'll go ahead and add these together. So what that leaves me with is the t's end up canceling. I'm left with negative 12c equals negative 600. Well, the negative signs are going to cancel, and negative 12 goes into negative 60 5 times, so 50 is the cost of a chair. So that's the cost of one chair. Let's find out what the cost of a table is. So I'm going to take that $50, substitute back in. So 4t equals 2. It's not equals. Again, I made that same mistake. So 4t plus 2 times 50 equals 200. So 2 times 50 is 100. And I'll subtract that from 200. And that leaves me with 4t equals 100. So dividing by 4 looks like the table's a little cheaper. So the table is only $25, where the chair is double that amount at $50. So those are the types of problems you're going to end up seeing. Good luck.